Ever wondered how atoms combine to form molecules and why they do so in specific ratios? Today we delve into the world of Stoak Geometry. A cornerstone of chemistry, Stoak Geometry is the calculation of relative quantities of reactants and products in chemical reactions. It is the mathematician of chemistry, the puzzle solver that pieces together why exactly two hydrogen atoms react with one oxygen atom to create water. Stoak Geometry is based on two fundamental laws of nature: the law of definite proportions and the law of multiple proportions. These laws explain how elements always combine in the same way, providing a reliable foundation for chemical equations. They are the reason why baking soda and vinegar always react the same way to produce carbon dioxide, and why rust forms when iron reacts with oxygen. Understanding how and why atoms combine in certain ratios gives us the power to predict the outcomes of chemical reactions. Now that we've established a foundation, it's time to put Stoak Geometry to the test. Stoak Geometry, in essence, is the mathematics behind chemistry. It allows us to predict the quantity of reactants needed or products formed in a chemical reaction. Let's consider a simple example: the reaction of hydrogen and oxygen to produce water. In this reaction, two molecules of hydrogen react with one molecule of oxygen to yield two molecules of water. But what if we want to scale this up? This is where the concept of the mole comes into play, a fundamental unit in chemistry representing approximately 6.02 times 10 to the 23rd particles of a substance. The beauty of Stoak Geometry lies in its ability to translate this molecular-level understanding to practical, macroscopic quantities. If we know how many moles of hydrogen we have, we can predict how many moles of water will be produced, and by extension, its mass. Similarly, if we know how much water we need, we can calculate the required amount of hydrogen and oxygen. Stoak Geometry is not just about counting molecules, it's about understanding the fundamental relationships between reactants and products in a chemical reaction. It allows us to plan and optimize reactions, minimize waste, and understand the world around us on a molecular level. With Stoak Geometry, we can effectively predict the outcomes of chemical reactions, making it a powerful tool in the hands of chemists. Imagine the power of predicting the outcomes of chemical reactions at your fingertips. Aminulchem. Innovation is a vibrant community of learners, sharing knowledge on topics as diverse as kinetic models to nanotechnology. Here, we breathe chemistry. Subscribing means gaining access to an ever-growing library of tutorials and becoming part of a community that's just as passionate about chemistry as you are. Unlock the world of chemistry at your fingertips. Subscribe to Aminulchem Innovation and keep the chemistry alive.